The finite gain model differs from the offsets model in that we can consider a finite input resistance denoted R sub I. We can also quantify a non-zero output resistance R sub O, and based upon these resistances, we limit V sub out to some finite number. The finite gain model is illustrated in the schematic to the bottom left, where we have two input voltages, V1 and V2. These input voltages establish the potential across our input resistance R sub I. We have a voltage-controlled voltage source where we have a gain A that provides a voltage output that controls V sub O. Now, this model does not include our non-zero bias currents and our non-zero input offset voltage. We can combine this model with our offsets model to have a high-fidelity operational amplifier model. Now, the governing equations for the finite gain model are as follows. Our output voltage, V sub O, is equal to A, the gain of our VCVS, times the quantity V2 less V1, plus R naught I naught. R naught is our non-zero output resistance, and I naught is our output current. I1 is given by Ohm's law to be V1 minus V2 per R sub I, and I2 is given via Ohm's law as V2 less V1 per R sub I.